All right. Welcome. My name is Jose Anunciado. And I believe we're all here for CS5610, yes? Yes. 5610, and I believe this is section 2. There's 2 graduate sections. Here in Boston, there's another section, third section over in Seattle. There's also an undergrad section that we're all going to be sharing the same material. We're trying to all keep pace together. Although the graduate version is going to demand much more of you. Many more involved projects and experiments and whatnot, and much. And then you participate more. Okay. There's a website that goes along with this course. Probably need to share my screen. This is the website, and there's a piazza that goes along with this as well. You should have received an invitation to Piazza. Anybody not received a Piazza invitation? A couple of you. So see me during the break, and then I can add you to the course. So this is the website. You'll be able to get access this from Piazza when you get the invitation. A little bit about myself. I've been working for at least 23, 24 years. The last 16 or 17 I've been software engineering. I've been doing consulting in all sorts of places with in different types of domains in the finance sector and telecommunications, healthcare, defense. So I have a lot of broad views on quite a few industries. Did my first, say, 9 years with mostly back-end. So a lot of server-side development, a lot of back-end, a lot of database and web services, exposing a lot of data services for front-end. I changed to the front-end about 6 years ago, and that was a lot more fun. I keep myself busy in both places as a full stack developer. So I find myself, creating the database, creating the data models, creating the web services, the back end, and then exposing all that to front ends, usually JavaScript, Angular, and I've also been teaching for almost the same amount of time. In various universities. Started teaching here about 3 years ago, almost 4. And I love teaching. I love to be able to bring you some of the anecdotes from industry, what people are doing out there in the front lines, and try to bring you a lot of the best practices that you see out there. So oftentimes we'll be talking about things that might look like it's an overkill for such a small example, but nevertheless, it's these are best practices that you acquire over being out there in the industry, seeing what how people are actually developing large applications, and what might not look as important when you're talking about a small project and maybe it's just you as a developer. It becomes very important when you're working on a large team. That has to be organized in a particular way, so that everybody is on the same page, right? That people find it easy to find things where they are, where they should go, so that the project goes beyond you, right? You're not the only one participating. There's quite a few other ones that you have to consider. And obviously your development is going to outlive you, right? Other people are going to grab your code and going to have to maintain it, modify it, and how can we be most efficient to participate in large projects. Right? Obviously, we might not have the time and the scope to be able to tackle large multi-year projects, right? But nevertheless, we like to expose you to a lot of those patterns that you will see in industry. This course used to be C#, .NET, ASP. About a year and a half ago, we decided to transition to the mean stack. We had a lot of, you see a lot of job openings with for this particular skill set, and also there was a lot of students coming to us about this particular set of technologies, and so we decided to transition over to this framework. Although a lot of the concepts that we'll see in this particular course are applicable, elsewhere in other frameworks. There's tons of frameworks out there. You pretty much do everything with any one framework, right? So a lot of things are similar. You'll often see me comparing various frameworks, J2EE, .NET, Ruby, PHP, or single-page applications using the mean stack. So I'll often contrast them and see why was it in a particular way, and how has it evolved into what we have today. Try to place what we do today, in its historical context. What is it that has changed, that has guided us to this particular moment, and perhaps trying to foretell where we might go from here. There's no book for this course. There's a couple of mean stack course books out there that you might want to grab. Although anything that is printed is obsolete. The technology is changing so fast. Things are moving so quickly that I find myself having to update the course from semester to semester just to keep up. My office is in West Village H. It's 460A, and I'll be holding office hours 4 days a week. You can find me here at 460A Tuesdays, Thursdays, and Fridays, not Wednesdays, because I'm here already. So I'm going to be here around 5 o'clock, maybe a little earlier on Wednesday. So if you want to come in a little earlier, we can chat. We can talk about any doubts you might have, one-on-ones. If you do have questions about the course, about a particular assignment that you're having trouble setting up your environment, or something's not working, please first go to the Piazza, ask the questions in Piazza, and perhaps other students might have the same questions. So if we answer it there, we'll answer for everybody. If you do have personal correspondence with me, you can definitely send me an email. My preferred email is j.anunzi@gmail.com. Although all the other emails, my CSS email, my NEU email, they should all point here. So anywhere you email me, it should be forwarded here. I'm also available on my phone number, 978. This is my personal phone number. Please don't share it with anyone else. But feel free to text me or WhatsApp me, or whatever you prefer. Or Google Hangout. Use my Gmail to do Google Hangout. Or if you prefer Skype, I'm at Jose.Annunziato. So it's first name dot last name at Skype, if you prefer. Phone, feel free to text me, WhatsApp me anytime. If you do want to call me, you can call me anytime. I would prefer you call me maybe around 5-ish. Okay. Any weekday, right, Monday through Friday. Between 5 and 6, you would help me between 5 and 6, except Wednesdays because I'm here. I commute back home, and after a long day, I'm drowsy. I'm trying to keep awake. If you call me between 5 and 6, you'd really help me stay awake. If I don't answer right away, I might be on the phone with another student. Just leave me a message, and I'll try to get back to you right away. If I don't answer, you just keep calling. All right, don't worry. Not after 10, but anytime, please feel free to contact me. All right. There are several TAs for this course, and they will be presenting themselves on the on Piazza, right, and offering different times of the day and dates and times that would best be suited for you for their office hours. So they will have office hours. I will have office hours. Okay. I'm suggesting that they take maybe Monday, since I won't be here on Mondays. I'll be here the other 4 days, but not Mondays. We'll try to have as much coverage as we can throughout the week. Please make use of their time. Oftentimes they come to me. No one came. I'm there. No one came to see me. So definitely, please make use of their time. They've gone through the course. They've gone through the same challenges that you will be going through. They've already solved them, and they're a great resource for you. Please make use of them. We are sharing this Piazza with 3 other sections, right? And we'll make every effort to all be on the same page. And the questions and answers should be equally useful for all 4 sections. If there is something that we need to say something specific to one section, we'll make sure to identify that particular section. But most everything should work for all 4 sections. As I mentioned, this is the website that goes along with this. My availability, this is kind of like an escalation. First ask on Piazza. If you don't get answers, then perhaps they go to the TA's office hours, right? If not, email, phone. Last thing you might, I'll be available in the office hours, but so will there be a lot of other students that might want to see me. So, first try out these other ways of getting a hold of me. Definitely Google Hangout, Skype. But if you must, obviously come to the office hours. So the only change that I need to do here is that on Wednesdays I'll be here in this room, since there's no class before this. So I'll just be here between 5 and 6. So I'm going to change this. I'll be here in 315 Baracus 315. Expectations. So there's 2 assessments. There'll be 6 assignments. There's a mistake here. It's 50% of the grade. So there'll be 6 assignments worth 50% of your grade, and another 50% will be a project. In the assignments, so they're designed to all build on each other. Building an actual project, right? A project that I have chosen, which the idea would be that as you progress, you're introduced to various topics, various technologies, and you would be ready to use those same technologies on your project. Okay, so this is kind of like I show you how to do it, and then you do it on your own, right? And as we learn how to do, as we handhold you creating projects, right? hopefully you'd be ready to tackle your own project that you choose, right? And ideally, we would be, tackling several features in this assignment, which you will be responsible for implementing similar features in the project. Okay, you'll be free to choose your own project. Although I have 10 or 20 projects of my own that I would love to share with you. If you can't come up with something, I certainly have plenty of things for you to work on. If you can't come to an agreement on what you're going to work on, then would hope that we can agree on one of my projects. Okay, and we'll be working closely together on those projects. But nevertheless, you're free to choose whatever you want. Ideally, you would start with the sky's the limit. Imagine you could build anything. What would it be? Okay, usually when you start designing something, stop being a developer. Don't be the developer. Be the designer, an artist. What would it be if you had unlimited resources, unlimited time and money to build something? What would it be? Right. Once you think of these things with no restrictions, then we can start talking about compromises, right? On how much time do you have, right? How much effort, how much time, how much resources do you actually have to accomplish, right? And so you might, out of this huge thing, you might pick out a subset of that, right? So yeah, don't restrict yourselves right from the get-go, right? Think of something really grand, right? And then we can come to compromise and say, well, this is too much or this is too little, right? And we'll scope it out together, right? And what could it be? There are certain features, there are certain technologies that any project that you choose will have to meet, right? There will be certain specific requirements, right? Such as you have to have some kind of user management, right? You have to be able to register and log in, and there'll be some private piece and some public part, right? The public piece of the project, anybody can view without having to log in, right? There'll be a private part that you have to log in and identify yourself to access certain portions of whatever it is that you're building, right? There'll have to be some kind of collaboration between users, either users sending messages to each other or finding each other or following each other, or somehow some kind of interaction between users. There'll need to be some kind of database and a data model, right? That you will need to store information. So there'll be a set of requirements that are equally applicable to any project that you choose. Okay? But I think these are reasonable requirements, right? That are applicable. But if for some reason you are choosing something that is very, very peculiar, right? That we can negotiate, right? That well, I want to do this instead of that, right? We can negotiate, right? Also, in the project, at the beginning, you don't know what you don't know, right? So a lot of things will be unknowable right now, right? And the scope might look okay at the beginning, but as you progress through the course, you find out new things, right? And it says, oh, I was hoping that I could connect, to the Federal Bureau of Investigation, but they're not making their APIs available. You find out, a third into the course. We can certainly, I would hope that you do a lot of this research up front as early as possible, right? That you do somewhat of a risk assessment on how likely is it that you will be able to complete this, right? One of the first things that you should do is, if you are thinking of connecting to some third-party API, is oftentimes that takes some time. It might take a day or it might take a week, right? Then you might have to register with them and ask for permission. You might have to describe the application that you want to work on and whatnot. Yes, and there'll be an application process, right? So that's time, right? And that's working against you. And it also, once you've been accepted for this particular API, well, does it accomplish what you want in the first place? Is it the right format? Is it the right data that I want? All right, so I would make those kind of research as early as possible, because those are the most time-consuming when you have to talk to someone else out there. Okay, so I would get started right away. Anyway, but more on that later. More on that later. There are no exams, no quizzes, just 6, 7 assignments, half the grade, and half the grade for the project. Okay, these are individual projects. You know, I have tried doing it with teams, and it is not clear to me at the end that both team members worked on it equally. It's not clear to me, so I'm not even going to try again, right? So you work on it individually. You're welcome to collaborate and, you know, ask questions and how'd you do this, you know, and maybe you're using the same API. Maybe that's okay. It is okay that, you know, 3 of you are doing restaurant applications. That 4 of you are doing movie applications, right? It's okay that 2 of you are doing travel. It's okay to do the same type of project, right? Certainly your work has to be unique, right? It is okay to collaborate and ask questions and see how one solves something else, but it is not acceptable for, you know, to blatantly copy somebody else's source code. Okay, it is okay out there in Stack Overflow or some library that solves your problem to reuse that library. That's okay, right? But if it's something that's not yours, you need to provide, you know, do where it's due. Right? Say where you got it from. Okay, don't claim it as your own. Right. Okay. The assignments, again, you can converse amongst yourselves on, you know, on certain you know, challenges that you might have faced, right? But again, your assignments are meant to be yours. You know, even though you will be able to view other people's source codes perhaps, and since we will be putting everything publicly available in GitHub, right? It is the expectation that all work that you submit is yours, your work. Okay. All the lectures are recorded, and they will be available here in the first module here, course videos. So, for instance, yesterday. We had I had my first lectures on CS5550. That's the undergrads, and I had my first lecture for section 1, CS5610, and their videos are already available. These are just playlists that auto add the videos, and yours will be here later today. Okay. So you can always come back and view the lecture. If you miss a lecture, you are responsible for the material that we cover in the lecture. Okay, so you know, I don't want to hear, you know, later on says, well, I haven't seen that in the requirements of the homework, or I haven't seen that in requirements of the project. Where is that written? Okay, it's certainly going to be covered in the lectures. Right? So yes, you are responsible for anything that is said in class. All right. Also, these are the various topics that we're going to be covering. You know, this week, the objective of this particular week is to set up a development environment and make sure that you're ready to go by the end of, not this Friday, but by the end of next Friday. Right? Make sure that everybody can deploy, right? Everybody can develop, everybody can create a hello world, Node.js, Angular application, right? That we can you know, be ready to start get going on the assignments and the project. Okay, so that's today. That's this week's goal. And all of these modules, if you notice, they all have a lectures tab. Okay, there's an overview that tells you more or less what the goal for this week is, or for this particular module, and also the lectures that go along with this module. And each module has several lectures that are associated for a particular topic. Right? So, for instance, there's a Node.js a set of topics. There's a Git set of topics and an OpenShift set of topics, and each one has a set of videos under there. Okay, these are pre-recorded videos, right? That you are responsible for the content in these videos. Okay, right. Again, there's going to be a lot of hand-holding on these videos. These are pre-recorded, right? And so they're not live, right? They're recorded in the studio, and they follow a particular order. Okay, so for this material, you're responsible for this material. So hopefully, what I'd like to do is that you watch these videos before you come to class, right? So maybe you come with with doubts, or you set this in the videos. Did I understand it right? Or you might have questions, right, that we might cover here in the lecture. Right? But the expectation is that you come with having viewed these videos already. Okay, that you might have done some research on your own, right? And that you might have some questions that we might cover here in class. All right. Okay. Again, you're responsible for what is said in class, but I might not say everything. Okay, but it certainly will be in these other videos. Right. So together, you're responsible for these lectures. You're responsible for the videos that have already been recorded. Okay. And there are 1, 2, 3, 4, 5, 6, 7 modules. Okay, and there are assignments for 6 of them. Right? There's no assignments for the last one. Okay. The first one, as I said earlier, is going to be focusing on getting you up to speed with a development environment. Okay. So as I mentioned earlier, we're going to be using the mean stack, right? And that means that so it's the mean stack. That means a mean is an acronym. It's an eraser. So the mean stack, it's an acronym. So the M stands for Mongo, which is the database in this technology stack. The E stands for Express, which is basically a module. It's a Node.js module, right? The N stands for Node.js. Right. And Node.js is the server. This is where we're going to be hosting our web applications. Right. And Express is just one of many modules that you can install, one of many libraries that you can install on Node.js that makes it very, very easy to create servers. Right. And A stands for Angular, AngularJS. And AngularJS will be the JavaScript library that we're going to be using on the front end, right, to be able to programmatically build our pages. Right. Notice that we have the 3 basic building blocks of a web application, right? We have where we have the front end browser, right? This is a view that we're able to manipulate the view using the A, right? Mean, the Angular. We have the server in the middle, which is going to be our Node.js, the server. Right, it's going to be N plus the E, right? The Node.js and the Express library together are going to be used to build our server. Okay, and the database, right, which is going to be the M here, the MongoDB, right? So we have the full stack, right? We have various technologies that are used in the various stack and the various layers. Okay, we have the Angular generating requests, HTTP requests to the server responding with static content. Okay, static content meaning HTML, CSS, JavaScript, and then Angular with the JavaScript, renders the application, asking maybe for more information from the server, asking for data, so that it wants to update the view. The server responds by going back to the database, asking for information from the database, queries, updates, deletes, inserts, right? And the data is then responded back to Angular for updating of the front end. Okay, so we have the various technologies that we need for the various layers in this stack. Now, oftentimes people say that mean is not a stack at all, right? It's just happens to be 4 technologies that work very well together. Right? There is no these 4 different technologies not necessarily are meant to work together. They just happen to work very well together. So Angular doesn't make any effort to somehow integrate with Node.js specifically, right? And same thing with MongoDB. Not necessarily MongoDB does any effort to integrate with Node.js. Right, so these are 3 different products, right, that happen to work very well together. Something that you find very commonly in industry is that for the server we don't have Node.js at all. We have maybe a Java server in here, right? Maybe some J2EE application, right? Either WebSphere, Oracle. That sits here. As long as this server knows how to talk JSON, right? As long as it can, receive HTTP JSON requests and generate JSON responses, right? Angular's good. It doesn't really care, right? Angular can connect to anything that can consume and respond with JSON. Okay. The server we're going to be using specifically is Node.js, right? Because we're going to be looking at this particular stack, right? Same thing with the database. Database doesn't necessarily need to be MongoDB. Again, going back to the Java example, very commonly that we were using some kind of Hibernate, Spring MVC that is using either MySQL or any other database, relational database. Right? Doesn't even have to be NoSQL database. Right? It could be a classical relational database. Okay, so you'll find Angular in several places, and all of these working together or not, right? But for this course, we're going to be focusing on the mean stack, right? It's a very popular combination of technologies that has been so popularized that has its own acronym, right? It's very commonly used. Okay. Any questions so far? All right. Let's look at the agenda for this course. I believe I made a mistake in this agenda. With spring break, I believe the spring break is the week before I listed it here. Okay, which is nice because it was bothering me that I was splitting the database development in half. So it's good because it's going to be the week before, and we can look at the database development, in two weeks together, as opposed to spread over 3 weeks with a spring break in between. So here, you notice that on the left-hand side we have the various modules, right? And they map to these modules here on the left-hand side, right? So there's the development environment. It's this one over here, and which is we're going to be focusing this week, right? And these are the four lectures that cover this. Although For you, you're only here on Wednesday, which is today, right? The other days is because of other sections, right? But the topics that we'll be covering today is we're going to introduce the course. We're going to talk about the schedule, the assignments, the project, and the various technologies you're going to be needing, right, to set up the development environment. Right, we're going to need 4 basic things that we're going to need to install during the next week or so, right? And hopefully by next Friday you'll be all set, all ready to go. The first thing that you'll need to install is Git, right? Anybody use Git? Okay, so most of you, that's great. So yeah, so if you haven't, you'll need to create an account in Git, right? We're going to be sharing all the source code in Git, right? You won't be submitting any source code through Blackboard, right? All your submissions will be through Git, right? As you work on your assignments, my hope is that you would work on them a little bit every day, right? What I don't want to see in Git, I could see your history in Git, right? I could see exactly what you did every day, right? What I don't want to see, peaks, right? Where you don't do anything for a long stretch, right? And all of a sudden you cram everything in just a couple of days, right? I do not want to see that in your history. I want to see just just even 15 minutes or half an hour or an hour, whatever. Rather you did some some activity on your Git history, right? So you should commit often, right, and frequently, right? So just make a little change here, commit, little change here, commit, little change there, commit, right? And you with a small comment on what it is that you did, right? So we'll be able to see all your history, right? I do not want to see these large peaks and valleys. I want to see something very smooth, right? That you have consistent work throughout the semester. Okay. So it's a great tool. It's a great tool to look over your shoulder what you have been doing for the entire semester. So yeah, definitely Git. If you have a Mac, you already have Git installed. If you have Windows, you have to download one of the Git Windows clients. The other thing that you need to install is WebStorm. WebStorm is the IDE that we're going to be using, right? And you might be already familiar with others, maybe Sublime or Wrangler or whatnot, or Visual Studio. Please, let's all standardize on WebStorm. Okay, it's free if you have an NEU account, which you should all have, right? You should register it with your .edu email, right? So that it'll be free for educational purposes. And it's widely used out there in the industry, so might as well learn the IDE. All right. There's never too many IDEs to learn. The other thing you'll need to install is MongoDB, the database. We won't be using the database for a couple weeks yet, okay? But nevertheless, it's a good idea to go ahead and install it right away, configure it. Configuration is very easy. It walks you through the configuration. The other thing you'll need to do is Node.js. You'll need to download Node.js and install it locally on your machines. And finally, you'll need to open up an account on OpenShift. OpenShift is all your assignments, all your project. You're gonna have to host it on a live server out there. Okay, I suggest OpenShift. If you prefer other servers, Heroku or some other service providers, that's fine. I might not be able to support you as much, right, if it's not OpenShift. And so all your assignments will be live available, right? So that we'll be able to run them and check them online. Your project as well, right? So definitely, and there's an assignment. This week's assignment is to set up all these things. Right? So we'll look at the assignment in a minute. right? What it asks you specifically. So following these are the next topics that we're going to be working on in the various weeks ahead. So next week, second week, we're going to be talking about HTML. Hopefully you already are familiar with HTML. You've already worked on some websites perhaps. We'll highlight perhaps the differences and a little bit about the evolution of HTML and how, why the latest version is what it is, right? The last specification, that introduces semantic elements and introduces, fills in a lot of the holes that were there in browsers, right? It's a recognition. Right? HTML5 is the recognition that that the web, right, that it's a legitimate development environment or a development platform, okay, as opposed to a platform for disseminating information or platform for consuming content, that's a legitimate use of the web. Yes, HTML5 is the culmination, is the realization that it's a legitimate development platform. You can develop web applications, full-blown applications that execute on the web. Okay, so we're not going to be creating websites here. Okay, I mean, yes, we're going to be creating websites that are pretty and nice to look at, but we'll be creating web applications. Okay, meaning that it's meant, these are going to be websites that are meant to be, heavily interactive with the users. Users clicking and dragging and as the user interacts with their web application, things are happening. So some database is being updated, right? It remembers what you're doing. It maintains a conversation with the user, discussion, right? And the user is able to interact with lots of data models, right? With lots of particular domain objects, right? Interacting with songs, interacting with movies, interacting with recipes or restaurants or teams or whatever, right? Whatever domain object you choose, whatever is the topic of your project, right? The user is meant to be interacting heavily with these pieces of data, right? Creating content, deleting content, updating content, sharing content with others, right? So it's not a website to share content, as a brochure maybe. We don't want that, right? What we want to do is, something that's heavily coded. There's a lot of heavy coding on the front end with JavaScript to, dynamically update the UI as the user interacts with the application, and also heavy coding on the server side, right? Where you have a lot of data going back and forth between the browser and the server, right? You're posting data and you're requesting data, right? You're deleting, you're inserting, and a lot of database heavy coding there as well, right? Where you're somehow mapping all this manipulation and you're storing it permanently on the database, right? So we're creating entire web applications, right? Not websites. Certainly, we are we want them to look, we want to wow the user, as a website might want to do, obviously, right? But we want to go beyond making it look pretty. Right? We want to make it a website, a web application. Right? So HTML5 is the I guess the first real version of HTML that recognizes that HTML is not just a presentation technology, but it is a legitimate way that we can build user interfaces, right, for an application, right? It introduces, controls such as date controls, right, sliders, right, color pickers. It introduces a lot of validation in the front end, right? That validates emails, validates phone numbers, validates ranges of numbers, things that you would need to build an application, right? So it introduces a lot of those new ideas, as well as introducing things that were missing in the specification that perhaps many other technologies was filling in that void, right? Early on, in HTML, in the first version, right? Well, even today, it's a stateless protocol, right? There's no way for different users accessing the same, talking to the same server. The server, there's no way for the server to distinguish, different users, right? So no matter who went to the server at requesting the same page, there's no way for the server to distinguish one user from another user. This is very limiting, right? Because you can't have data that is, or a website that is specific to a particular user, right? Imagine I want to have a shopping cart. It's my shopping cart, right? That's not somebody else's shopping cart, right? We want to show information that is for a particular user, maybe also for a particular region. Where are you, right? Depending on where you are. I want my weather. I don't want his weather, right? I want the weather where I am, right? So I want location. So early on, we HTML doesn't start supporting these kinds of things, right? And to fix this throughout HTML, we've had many plugins, right, that expanded the features of browsers, right? We had Java applets that introduced the ability of having animations and user interfaces that were a little more sophisticated and fully interactive. Flash introduced also the ability of creating very interactive applications, full-blown applications, and these were plugins, right, trying to fill in the void, right, and streaming video and streaming all sorts of content. HTML5 again is tries to fill in those gaps, fill in missing technologies that we needed, right? Where now streaming videos is now native to the browser as opposed to needing a separate plugin. Okay. So we'll look at HTML5 on next week. CSS3, we'll see how we'll see why the two, right? Why HTML and why CSS, right? It's we'll notice that early on when HTML first came out, you had just one type. It was just HTML, right? If you wanted to things to lay them out in a particular way, you would use maybe tables, right? If you wanted to make things bold or underline or color, you would style it right there in the same HTML file, right? If you wanted to add some interactivity, you would right instead of the same HTML file, you would add scripts or you would have plugins, or right in the same HTML file. Well, these technologies have grown. Have grown on their own, right? Have matured enough, right? That their own particular skill set, right? And certainly CSS is its own skill set, right? Of styling, of making things look pretty, right? And laying out things in a particular way. So it's its own skill set, which we'll also spend next week talking about. And one of the things is that we wanted to optimize and make people learn certain particular skills that were for a specific goal, right? Of styling a page or laying out a page, right? Or programming a page. Today you can find people that are specifically just HTML and CSS. That's it. That's all I do, right? And people that only do JavaScript, right? A little bit of HTML, and you have some collaboration between the two, right? Certainly developers are not very good at making things look pretty. We have a very functional way of thinking, right? And I got it to work. It does what I want it. Right? I don't care what it looks like. Right? It just does what it needs to do. Right? What else do I want? Right? Certainly, a lot of us as developers, we're missing some of those skill sets, right? Of making things look professional, finished, polished. Right, and hopefully, we want to push you towards making it look polished, making it look finished. Right? Is this something we'd be proud of? Right? Giving a link to your next employer. Right? Would you be? Is this something you would put in your resume? Right? Hopefully, that's the intent of your project, of your assignments, is that for you to develop something that you would be proud to put in your resume. Okay, and go check this out. Right, put it in your resume, and somebody goes there and says, "Wow, you're hired. Okay, that's the intention, right? So I will be the first hurdle, right? Reflect, right? What I think your next employer might think of your project, right? If I give you an A, I will feel confidence that if you give out this project to your next employer, they will call me and says, "Wow, your student did a great job." Okay. If I don't feel confident that that employer will feel that way, you won't get an A. Okay. So whatever project you come up with has to really wow. It says it looks like you put a lot of effort into this. It looks finished. It looks like beautiful. It looks wonderful, right? Okay, so next, so we'll talk about CSS3. We'll talk about responsive design. We'll talk a little bit about the evolution of the web and how today we see that most people are consuming or visiting web pages in their phones, right, in their tablets, on small devices, and certainly we want to cater to this growing population, right? This growing demographics. More and more people are just using small devices, so it would be foolish not to think of them, as our main, right, audience, right? And so we'll talk about the philosophy of mobile first. Now, you should first focus on what should your application look like on a phone, right? And if you had a little more space, right, maybe on a tablet, what else would you show, right? As you have more space to show, what else would you show, right? And then once you have a desktop, a large screen, what else would you show now with a bigger screen, right? But thinking about your main audience, right, on the phone, really makes you think in a particular way, right? On what is it really that I want to show, or what is my main piece of information, right? It makes you think twice on what is that you want to show on such a small screen. What I want it to show up at the very top of my screen, right? So they don't have to scroll, right? And how deep do I want to make my my navigational tree, right? How many taps will they have to do, right? Once to get to navigate deeper and deeper into my application. So it makes you think a lot about how you want to organize the data and the navigation, right? And it makes you think about how you want to optimize those things, right? Once you have more space, then you can splurge a little more. It says, I'll keep the navigation, right? But now that I have more space, I might show more things, right? We don't want to instead go the other way around. We don't want to think first about the desktop, right? And then say, oh, once I have the desktop done, oh wait, how do I transition this to a phone? That's a much harder, that's a much more challenging task, right? On growing the other way or shrinking the other way, right? So one of the first things I'm going to do with your project is visit it with my phone. Okay, and right off the bat, if it doesn't look nice on a phone, right? You've lost 5 or points on your project, right? You no longer have the A, right? But it has to be phone friendly. Okay, that's going to be one of my main criteria, right? Does this look beautiful and works perfectly on a phone, right? On a phone. But then I'm also going to do it on a browser. I'm going to shrink the browser to see what it looks like on a browser, right? So for instance, one of the first things that I'm going to try to do, does it have scroll bars at the bottom? Right? It should not have any scroll bars at the bottom. I should not, for instance, look at the phone, right, and be able to zoom in or zoom out, right? That should be turned off, right? Because this is not a web page, right? Right? I should not be able to scroll. I should not be able to grab it, right, and scroll left and right. Right? It should stay fixed, right? Unless you mean for that to happen, right? If right, or scrolling or it must be because you meant it to be, not because you forgot, right? That, oh, I need to check for that, right? It should, any behavior is because it should be a deliberate behavior. Yes? Okay. If there's some content that wraps, right, because the title is too long, that looks beautiful on a big page, but when you shrink it, it wraps the wrong way, right? Again, right? You might lose points on that, right? So if you want wrapping, make sure that it's the wrapping you meant it to be. Okay, make sure you look at it, and you look at the wrapping. So it doesn't look right, right? Right? What's styling? What else do I want to style it with so that it looks okay on both, right? On large screens and small screens. Right? If you want wrapping, make sure it's the wrapping you intend it to be. Right? It's because you meant it to wrap, not because you forgot to check to see if it wrapped correctly. Okay. Right? So everything should be intentional, right? That it should behave the way it is meant to behave. So yeah, so responsive design, we're going to spend quite a bit of time on doing that. To achieve responsive design, there's quite a lot of styling libraries out there, okay, that make it easy to implement responsive design websites, right, or websites that are responsive. One of them is Bootstrap, which that's what we're going to be using throughout the course, right? But before we get to Bootstrap, we'd like to see how Bootstrap, achieves its magic. Okay, Bootstrap uses what is called a grid system. Right? A grid system is an idea that we in computer science we copied from the printing industry. The printing industry is fairly mature, right? They've been around for several hundred years. Even before the printing press, right? People were laying out books and making things look pretty, right? But ever since the printing press came along, right? People have been printing, books, in a mass scale, right? Or printing newspapers and things like that, and they come up with a fair amount of good practices, right? Of showing things in rows or showing them in columns, right? And headers and footers and asides, right? And articles. So these people have thought about it really, for quite a while on how is it an appropriate way of displaying written content. Yes. So we copied a lot of those ideas and we came up with a grid system, right? It's basically a collection of rows and columns that maybe flow into each other, right? To be able to have many columns or columns that flow into one another, that span across various columns or span across various rows. Early on in HTML, we used to use tables for that. Right? We used to use tables for laying out things or rows and columns and whatnot. Today, that's considered bad practice. Right? Tables should be used for what their initial intention was, for tabular data. Things that have headers and have and data that have a particular data type, right? That go along are displayed in the same column, right? That's tabular data. Tables are meant for that. They're not meant for laying out content, right? So instead, we use grid systems. Right? So we're going to build our own grid system, right? So that just to get a handle on how do they work, right? How is it that you create elements that behave like rows and columns, right? Also, we'll build a responsive grid system, right? Meaning, if I have a large screen, yes, I want to show things in 4 columns. But as my screen shrinks, right, and four columns is no longer appropriate, right? 4 columns on a small screen is, it's illegible, right? I can't read that. I can't read 4 columns on a phone, right? Instead, what I would like to do is perhaps those 4 columns become stacked, right, one on top of the other on a phone, right? So how do I create grid systems that respond to the size of the screen? Right, so we're going to create responsive grid system when we get there. We're going to create a simple one, very simple one, right? But once we understand what the magic is, right, how it works, once we understand the, where we learn our multiplication table, right, we'll give you the calculator. right? And we'll say, okay, well, now that you understand how it works, we'll move on to Bootstrap. We'll see how Bootstrap does it. And it'll be very, very similar. We'll follow. Your question? Oh, no? Okay, no, sorry. We'll see how Bootstrap does it, right? And we'll use a very mature grid system, right? It's industry strength grid system that does quite a bit more. Okay. With Bootstrap, it's very easy to make your applications look wonderful, right? To look already responsive. If you stick to the Bootstrap layout, right? How to lay out your application, then it'll be very easy for you to create applications that are responsive, right? That look nice on the phone, okay? That look professional, right? If you're thinking, oh, I'd like to do something like this, layouts or a couple things like that, go see if Bootstrap already has a solution. Chances are that Bootstrap has what you want. Okay. If it's not there, okay, then you can start thinking about how to do custom implementation. But first, reuse what's already out there. Right? Bootstrap has quite a bit of snippets that you can just copy and paste. Right? You'll hear me say this over and over, right? Throughout the semester. It says, I'm going to look at your implementation. It doesn't look quite right. It says you didn't use a standard Bootstrap layout. Right? Go back and see what Bootstrap does. Okay, right? All right. Okay. So yes, use Bootstrap profusely throughout your semester. So yeah. So the first 3 weeks, mostly we're going to focus on static content, right? HTML, CSS, layout, right? Laying out your application. There will be an assignment, right? This assignment is called the user interface development assignment. Excuse me. What's going to do is, remember, these 6 assignments are geared to work one after another, right? Build on each other, and they're designed to mimic or parallel what you're going to be doing in your projects, right? So in this first one, I'm going to be giving you wireframes, right, of what I want the application to look like, right? And I'm going to ask you use the HTML and the CSS and the Bootstrap, right, that we've talked about in class, right? Go out and build me this wireframe. It should look like this, right? Use Bootstrap to make it look like this. Okay. If you use Bootstrap, it'll be very, very easy. Don't use Bootstrap, you'll just be pulling your hairs out. Okay. Okay. So coming up with a wireframe, coming up with the laying it out, what it looks like, and prototyping what the navigation might look like. You should do the same thing for your project. In your project, you'll have to come up with wireframes, right? You have to create some prototype of what the pages are going to look like, right? You're going to prototype the navigation to see if it looks right before you actually make code and do any JavaScript or any server side or any database, right? You'll be prototyping what the navigation looks like and laying out the various pages, right? So hopefully that's what you'll be doing for your project. But on the 3rd week, right, when notice that there's more than 6 assignments. There are going to be assignments that work towards completing the project that I am assigning to you, right? There's 6 assignments for that, right? But then parallel to that, there's going to be assignments for your project, okay? Where the first one, for instance, is going to be come up with a proposal. Propose me what is it you want to build, okay? So that's going to be one assignment. You're going to have to tell me, I want to create. I guess a lot of folks like to create soccer teams or many other sports-related applications, right? Or restaurants. A lot of folks like to do restaurant applications. So I'm going to use the Yelp API or Yumly API, and I can search for recipes. I can search for types of ingredients, right? And users are going to be able to save those recipes, load recipes. People are going to be able to comment on each other's recipes and share recipes, right? So you'll come up with a couple paragraphs describing your project, and you'll describe the various an API that you're going to be using. I'm going to be using Yummly to search for recipes. I'm going to be using maybe Google Maps API to GPS position the person where they are, and show a map of where certain deliveries, food delivery, or where the restaurants are located, maybe. All right. So you're going to propose that to me on the third week. So you better start thinking about this real quick, right? The proposal is not set in stone. Okay. Again, you don't know what you don't know, right? So first come up. I want you to start thinking about what you want, right? Again, imagine you could build anything. What would it be, right? So in your proposal, describe to me what would it be that you would have. Describe to me a couple use cases, right? Users are going to be able to create recipes. Users are going to be able to update their recipes. Users are going to be able to share with other users. Users are going to be able to search their recipes, right? Users are going to be able to browse through several pictures of the finished product, right? People are going to be able to comment on their recipes. So all those are use cases, right? What are the various goals that users are going to be able to accomplish with your application? Okay, that's in your proposal, right? Start thinking about the various entities. And you have done database before? Okay, so most of you, right? Right, so you start thinking about what are the various entities, what are the various objects, the domain objects, right? Recipes, restaurants, users, right? And start thinking about what a class diagram might look like, right? Of one-to-many relation. A user has many recipes. A recipe has many ingredients. Yes. Or users has many favorite restaurants, right? User are following many other users, right? All those relationships. Start thinking about what are these relationships, right? So you might want to put your first iteration of what that might look like in your project proposal, right? So a lot of design in your project proposal. So that's the first 3 weeks. Notice that each assignment is due quite a few weeks later. Notice that for the user interface development, notice that it's due February 5th over here, a week after we complete all the material, right? So for the user interface, because the user interface development assignment, you need HTML5 and responsive and Bootstrap. We won't have covered everything until the end of third week, right? But you should be able to start thinking about it, right? So it's not until a week after that you'll actually be due. Right? Project proposal, same thing. You have a couple weeks for that. Right? You have to February 12th to come up with a project proposal. So hopefully by then, that's the end of the 5th week, right? By the end of the 5th week, I hope, right, that you'll have matured enough that to come up with something. Maybe you've done some research on the APIs. Is this the API I want to use? I've tried it. Maybe I've done some small prototyping, right? I know it has the data that I want. They've accepted my application for a key, for an API key, right? Okay. Also, if the project is you're choosing it on your own, if it's a project that you're choosing it on your own, it has to use a third-party API. Right? It has to use a MongoDB database. Okay. If it's a project that you're doing with me, right, and we'll see a list of them. Well, not all of them needs a web API. Some of them don't. Some of them do. Actually, most of them don't. Those don't need to use APIs. Okay. Anyway, let's see. Let's continue. So yeah, up to the third week, we've been doing a lot of just static content, HTML and CSS. Starting week 4, we'll spend 3 weeks talking about JavaScript. Okay, so JavaScript, I believe this has been recognized as the language of the web, right? It's the programming language of the web, right? It's the language that we use to program the browser, to interact with the browser, right? It's how we can make the browser interactive, right? Although we'll already have seen some interactivity, very minimal. For instance, as with CSS, you can accomplish some interactivity, right? You see that it's resizing and repositioning things, right? As you resize the window, so you can do some interactivity with CSS. But with JavaScript is where you have full control of the browser as a development platform. Okay, you can display dialogues, you can interact with forms, you can manipulate the interface, right? You can add content programmatically, remove content programmatically, update content programmatically, show content, hide content, right? Handle all sorts of events as a user clicks and drags and interacts with the browser, right? And we can manipulate the user interface as the user interacts with the JavaScript, all on the browser, right? Now, being on the browser, it has some limitations, right? For instance, JavaScript is code that has been downloaded from the browser and it's now running on somebody else's machine, right? You wrote the code, you're hosting it on a server, somebody came to visit your page, right? Downloaded the HTML. That HTML then requested a JavaScript, downloads the JavaScript, right, on their browser, right? And this gives us some limitations, yes? It's not JavaScript, it's not code that is running on the server where we host our content, it's running on somebody else's machine. Because it's running on somebody else's machine, there are security concerns, right? That other machine is not going to let you, for instance, access their file system. Well, minimally, right? Allow you to maybe maybe browse for content that you want to upload. Maybe that's it, perhaps. Yes, you want to upload a file or an image, right? But that's about it, right? Also, we don't have a database on the browser, right? We don't have anywhere to store data. Well, we do. Some minimal data, right, on that browser, but very, very minimal. Nothing very important, right? So we're very limited on the browser, right? Also, we're contending with issues such as what browser is the person using? Maybe it's the latest and greatest version of Chrome, right? That supports all the latest and greatest features of JavaScript, or it might be a very old browser, right? It might be IE. Not what we do. We're very restricted with those versions, so we can't control the browser that our code is going to be running on, right? So one of the concerns is that challenges that we have to figure out what browser is it, right? Which vendor, which version, right? And we don't control that, right? And so we have to figure out, do they support GPS? Do they support this? Do they support this other feature, right? And that it would be a nightmare if you have to write all sorts of if statements. If it's Chrome, do this. If it's Safari, do that. If it's IE, do this, right? If it's this version, do that, right? It would be a nightmare, right? So to solve that, what we might do is perhaps encapsulate all these checks, right? Of what browser it is, what version. We might encapsulate it, right? And maybe instead of having it spread out all over our code, maybe we have libraries, right, that encapsulate this logic of what version, what vendor. Right? If we iterate that idea of kind of like abstracting the browser, I don't want to know what browser. I like to be able to write to a consistent browser, right? Right. I would like to create some kind of API that abstracts the fact that it's this version, it's this vendor. If we iterate that idea, we end up with jQuery, right? So jQuery is a library. It's a JavaScript library. It's one of the most popular JavaScript libraries that does exactly that. It abstracts the browser, right? So we don't have to worry about what version of browser we're working with, right? Instead of working natively with JavaScript, we write on top of the jQuery library. Okay, we use the APIs of the jQuery library. Then jQuery will figure out, right, what version, what vendor it is, right, and do all the right things. Right, we'll do it using the various idiosyncrasies, right, of each browser, each vendor. Make sense? So so certainly jQuery will make it's a layer of abstraction, right? It creates like a virtual browser, right? Instead of writing directly to the it's almost like the JVM in Java does, right? The JVM in Java, the original intention was that I don't want to have to code for for this particular architecture or that other architecture or that other architecture, right? Where you might have different libraries, right? I don't want to have precompilers that figure out what do I compile in which order, right? Instead, I write to a virtual machine, right? So jQuery is like the JVM of browsers, right? Plus, it has many other things. Lots and lots of libraries, lots of really cool plugins that extend the capabilities of JavaScript. You can make things draggable and resizable and dialogues and all sorts of really cool behaviors. Okay, so we'll spend some time talking about jQuery. We'll talk about JSON, right? How do we represent data, right? So our applications are going to be very data intensive. Again, these are not going to be websites, right? Static websites. These are going to be very dynamic applications, right? What I mean by an application is a little bit the history here is, again, at the beginning, HTML was very limiting, and we were adding new plugins and plugins that were adding more interactivity, right? Now we reached a moment where we have JavaScript allows us to have that interactivity. But as more and more people started using the web, right? They were transitioning they were coming from working with desktop applications, right? Once we stopped using mainframes, we started having machines that were powerful enough to be able to install entire applications on our machines, right? And have them running locally on our machine, and have them interact just with us. So we were coming from a mainframe where we have dumb terminals, right? And the application always ran on the mainframes, right? And I don't know if you're old enough to remember any of this. You would type something, it would go to the mainframe would run, and it would come back with the results, right? You would type the very very dumb terminal. Once computers were powerful enough to have applications install on our machines, you have this software explosion of people developing applications and you installing it in different versions of the applications running, and they're buggy and you iterate over many versions of a particular application. Today it's kind of like going backwards, right? It's going backwards. Applications are now moving back to the mainframes. Right, and having them run centralized in a single place, right? And then we have somewhat of a dumb terminal. Yes, you have a question? So it's kind of like it's funny to see how technology comes and goes again, right? And see these patterns, right, over time. Although our terminals are not as dumb as they used to be, right? And from those years of having these dumb terminals, we've been pushing the idea of having thin clients. You have the main application is running centralized, right? And what you see in front of you is a very dumb, thin client. It's not doing anything. It's just displaying. It's just displaying data and then just grabbing some interactions, right, with you, and then sending it back to the server for processing. But the client in front of you is very dumb, right? Anyway. So there was several decades of desktop applications. People became very impressed with what you could do with the desktop applications, right? They're very responsive, right? very reactive to you, right? Because you were the only one who they were interacting with, right? You could drag things around, you can resize, you can move things around, very, very interactive, right? As more and more people started using the web, right, they kind of started expecting the same kind of behavior, right? And what they were finding is that, it's very clunky, the kind of interaction that they would find in the web, right? They would click on a form, the form would submit, right? The whole page would refresh, right? The whole thing would re-render. It was very clunky, right? Even the page was meant to stay mostly unchanged, the whole thing would re-render, right? Just look at some forms, right? You're submitting a form and maybe you mistype the phone number, or you mistype an email, right? It goes, all that information goes back to the server, and the server spits back an error saying, no, you're missing an email, you're missing whatever. The whole thing would re-render, right? Even though there was this small little piece, right, that was wrong, the entire thing had to be re-rendered, right? Very suboptimal, okay? So that's not the kind of interaction that users were looking for coming from desktop applications that were extremely sophisticated, right? They were looking for the same kind of experience, right? The first kind of application that I think illustrates the kind of interactivity that we're looking for, at least the one that first hit me like an epiphany, is when I first used Google Maps. Right. The first time I used Google Maps, and so I had used MapQuest. I had used many other applications where if you want to map, you have a map and you want to pan right, you have buttons on each side, right, on each vertex, which says I want to go right. So you click on a button and you pan right. The whole thing would re-render with a new map, pan right. And it worked. I mean, it was functional. Some developers said this is good enough, right, and they didn't go beyond the functionality. They didn't go and consider, a better way of interactivity. How could it be this? How could this be better? So in Google Maps, when you first grabbed it and just flicked the map, and you had this very smooth scrolling of the map, and the images, automatically render, loading on demand, to fill in those gaps that were missing. That I thought that was amazing. It says, wow, this is the kind of interactivity that we're looking for, right? This very, very dynamic, fetch the content on demand and fill in the gaps. No need to refresh. I'll just go and fetch the pieces that I need and just update the pieces that I need. There's no need to refresh, right? And this started an entire iteration of many types of these types of applications that now we consider them as single page applications, right? Applications that are loaded once, right? And then they load the other content on demand, right? They for instance, Google Mail, Gmail, right? Again, another nice single page application. And you click here, click there, and it updates dynamically, as new email comes in and you send, and when you start a new one, it looks like you transition to another page, but the page never reloads. I don't know if you realize that, right? The page never reloads, but it's showing you a new page, dynamically. And then when you're done, you send it, right? It goes back to the previous page, right? All in the same page, it never reloads, right? All this content is dynamically loaded, right? And disposed of when you don't need it. It gives you the same functionality of navigating between various sections of the application, right? Various views of the application. It gives you the navigational functionality, but it's not implemented, right? The way we classically implement navigation in HTML, right? Where you click hyperlinks or you click on buttons and you navigate to another page, right? And refreshing the entire page. That's the classical way, right? So this is so single page application. That's where we're going to be focusing this course. Single page application. That's where most of the successful applications, Twitter and Facebook and all these applications have become single page applications, right? Very seldom do you see the entire thing reloading, right? What allowed single page applications to be successful is this technology, Ajax. Right? Ajax is the technology that allowed us to dynamically fetch new content. And just to illustrate a little bit, how is this different than what we've seen earlier? Let me just stop sharing for a second. So anatomy of an application. Right? In the classical implementation, a user here navigates to a particular URL, to a server, right? And asks for maybe index.html, right? And then they consume index.html on a browser, right? So this gets downloaded on a browser, right? And they interact. So this is the browser, and they interact with the application, right? Perhaps clicking on a link, on a hyperlink, right? And this is asking for another document, for another HTML document, and that document then gets, perhaps, contact.html, right? Or about us.html or products.html, right? And it gets downloaded, and the whole thing loads. The page loads. The index is unloaded, right? And the new page is loaded, right? Or, for instance, when we introduced some dynamic features, what we started doing is things like this, where we would ask for not index.html, but maybe index.php or index.jsp or index.asp, right? These were dynamic pages, right? That were computed dynamically, right? These were not static pages, right? So, for instance, if it's a JSP, then the server would find JSP, would compile this, right, to a class, and then would execute the equivalent class, right? And that class, would have access to maybe a database, a local database, right, with query. Right, and then it would inside of the JSP would have code, right? Would have if statements and for loops, and right, and have all kinds of logic. It would execute on the server. This is on the server, right? It would execute on the server and then spit back plain old HTML, only the HTML, right? The source code would never go back, right? The resulting HTML would be pure HTML, no source code. Yes, right? And then the user would perhaps ask for another page, right? And that page, again, another PHP or JSP, would execute again on the server and come back as plain old HTML. Yes? So this was server-side dynamic pages. Server-side dynamic. They were dynamic because, right, it was calculated on the fly, right? Whatever content was dynamically calculated, right? But even here, if you say you have a form, right, and you submit that form and it's wrong, it would go out to the server. The server would execute and check to see the data that was submitted, right? If something was wrong, it would spit back the same page, maybe with some metadata saying that the email was wrong or the phone was missing or whatever, right? But it was the same page. It would reload, right? This page would load, right? It would kind of flash, right? It's kind of a little, just dump the entire HTML and then reload almost the same exact HTML. Very, very wasteful, right? Because 95% of the content is the same exact content, right? It kind of flicker, right? So that was somewhat wasteful. We improved it with perhaps maybe not only downloading the HTML, maybe we download also an accompanying JavaScript, perhaps, right? With a company of JavaScript, which maybe could do some initial validation, right? So it would not bother the server with bogus data. Do some pre-validation. Check to see if all the required fields are filled in. Check to see that the email is in the correct format. Check to do some preliminary validation, and so that I would skip this, sending or posting the data with bad data. So that was a little better. That was a little better, right? We have some JavaScript to do some validation here, and maybe validate, highlight, right, the content as you go. Yes, that was a little better. But again, there was some flickering, right, as you navigated between these two things, right? Certainly, you could drag and drop things, right, and have them updated in the database, right? Imagine you wanted to drag things around. How would you save that? That statement back on the server, right? So today, right, in newer single-page applications, we are no longer going to do content, right? All the dynamic content is going to be generated on the client side, on the browser side, by JavaScript. Okay, so we're going to ask for to the server. We're going to ask the browser is going to ask for index.html, HTML, right? So static, right? No dynamic content, right? Once index.html downloads and is copied locally on the server, it's going to ask for JavaScript. It's going to ask for a couple of JavaScript libraries. Plus, it's going to ask some cloud service for Angular, right, and some other JavaScript libraries as well. Bootstrap is going to download Bootstrap and all those things, right? So together, right, they're going to dynamically, using JavaScript, manipulating the document, right? They're going to dynamically, using its own if statements and for loops instead of JavaScript, dynamically render that page. Okay, and if I navigate, this is not going to be a regular HTTP request for another page, right? I'm going to have snippets here. I'm going to have various snippets, one for contact and about, all HTML templates, where I'm going to be dynamically retrieve using Ajax. And retrieve this and then update various portions of the application. Maybe a small piece here. Maybe the body, not the header, not the footer, right? Not the sidebar. Maybe just the content, just the main content. Okay, just the main content. So Ajax, right? Ajax is a technology that allows us, right, to under the covers, right? Under the covers, without submitting the entire page, communicate with the server underneath programmatically and ask for content, ask for data. Okay, Angular is going to use Ajax to strategically ask for various HTML pieces, yes, and then include them and build the page dynamically, right, and provide navigation, right? If you click here, if you click there, as I click, Angular is going to ask for the various pieces and build the page dynamically, right? We're also going to be using Ajax to ask for not HTML content. We're going to ask for data. We're going to ask for JSON data, JavaScript data. It says, hey, they just added a new recipe. Here's the data for the new recipe. I'm going to send that data for the recipe, and that's going to go, right? New recipe goes to the server stores in the database. It comes back, says success. Yes, I was able to add the recipe in the database. And then JavaScript is going to say, oh, you did? It was successful? Okay, I'll render it as a new entry dynamically. I'll render as a new entry in the table that lists all my recipes, right? Without having to refresh the page or anything, right? I'm only updating a row in a very big table of recipes, right? Or get, right? I can post new data. I can get new data. Get me all the recipes for this user, right? I'll give you the ID of the user, and you respond with an array of recipes, right? And then I will dynamically render a table of recipes without refreshing the entire page. Makes sense? Right, so that's the how things have evolved over time, right? These are single-page applications that we're going to be implementing. Index.html is the only page that ever loads, right? And then everything else is dynamically loaded on demand. Make sense? We never navigate away from index.html. We never leave the page. It looks like we're navigating from one page to another page to another page. We have the functionality, the same functionality you would have if you would actually navigate to other pages, right? But it's implemented differently. Okay, it's not implemented the classical way of navigating from one HTML page to another HTML page to another HTML page. Make sense? So yes, Ajax will allow us to do that. So finally we'll introduce Angular. So Angular is one of several popular libraries that that have taken the web development by storm. Okay, AngularJS introduces many concepts that have proven useful on the server side. Okay, and we're gonna implement many of those features on the client side, right? Things such as modules, right? Such as design patterns, such as MVC, model view controller, right? Things such as injection or inversion of control. These are all concepts that we're very familiar on server side. They've been implemented there for quite a while. From the late last century, right? They've been around in J2EE, in C#, right? In .NET, on server side. They're very common design patterns, right? And lately they have been, they've become mature enough. They've become mature enough that they're copying the same ideas and applying them on the client side. Also because the client side, JavaScript, because we're building more and more sophisticated user interfaces, right? They require this kind of complexity, right? Of being able to break up large things into smaller pieces and start to think about design patterns. How do I what should go where, right? So model view control has proven very, very effective at breaking up larger applications into different buckets. Okay, one of these buckets is the model view controller, and AngularJS builds on this design pattern, right? So let's review that design pattern just real quick. So yeah, it uses the design pattern called model view controller. So usually it's oftentimes referred to as an MVC JavaScript library, right? And there's quite a few out there, okay, which Angular is one of the more popular ones, right? And basically what it does is that whenever you're building something, whenever you have a file you're working on, right? That file should be in one of three buckets. Okay, it should be either interacting directly with the user, right, the view, either rendering something, displaying something for the user, okay, displaying a page or a table, rendering things, right? Or it should be receiving and handling events as a user interacts with your application, right? As a user clicks and drags and scrolls and does things, right, with the user, they generate events. They generate a stream of events, right? Or if they're on a phone, perhaps a stream of gestures. Okay, and those gestures, are handled by a controller, right? So there's a controller that handles all these events, right, and maps them to some kind of action. Something has to happen. They just added a recipe. They just removed the recipe. They just updated a recipe. Okay? They just listed all the recipes. They're looking at recipe number 1, 2, 3. Right? They're doing one of four things. Right? They're either creating, they're either reading, they're either updating, or they're deleting. Right? Something. Right? Those are the four basic operations. As they interact with anything, right? So those are converted into some kind of manipulation on the data, the model, right? So these are the various operations on the model, on the data. What's your data? An array of recipes. Each recipe is an object, right, with various attributes, right? You either can create a new one, you can delete a new one, an existing one, you can manipulate an existing one, right? You can list them, you can look at one in particular, right? So as this stream of events generates these CRUD operations on the model, as the model gets updated, the view takes a look at it and says, oh, something changed in the model. The model was modified. I'm going to go ahead and re-render that. Right? Re-render it of the view, right? So that the user sees a visual representation of how that model has been manipulated. Okay. Along with this, so Angular fully supports this, right? It forces you to think in this way. Right? Some people see that as a limitation. It says, oh, you have to build it in a particular architecture. It forces you to build it in a particular way. That's a good thing. Okay, it makes it easier to find your way and where are things. What is this file I'm looking for? Oh, it's a view. Okay, right. It's a controller. It's a model, right? Along with that, it forces you to think about. Here's a server somewhere. So this is on the client. This is on the browser, running on the browser. So here's a server, and we have to communicate with the server. As you change the model in the view, it also has to change in the server, because if I log out, when I come back tomorrow, I want to see my changes again, right? So I need to notify. I can't store it in the browser. I need to notify the server saying, hey, the model changed. Okay, I want to store this because this, right? So also Angular, has the notion of services. Services that communicate with the server. Communicate with the server, sending HTTP posts and gets and deletes and puts, right? That update the data model, right? And then come back with the results for rendering. So and then the server stores it in a database for permanent use. Let's take a quick break, right? And then we'll come back right after these messages, right? There were a few of you who were not in Piazza. If you could come down, I can add you. How you doing?
Good to attend this class. I'm really excited. Professor, I have a request. Actually, this class is like conflicting with my other class, that is software vulnerability.
Okay.
So could you just move me to the other batch, maybe Tuesday and Friday batch?
Oh, why don't you just come? I need to move you.
But the problem is I cannot register my course.
Oh, you can't. Okay.
My NU is like giving me a conflict issue, saying that I cannot register the course.
All right.
So do you have the rights to move me to the?
Yeah, Brian Lackey can do that.
Okay, because I dropped email to Denny, she is not replying to it. So
no, send an email to Brian Lackey.
Okay.
CC me, right? And then if you had any questions, I can answer that.
All right. Awesome.
Right?
Okay.
Awesome.
Thank you so much.
Hi.
I actually did register for a course day before yesterday. That's why, because
same with me.
Okay.
I registered yesterday.
Okay.
I was in the other batch, so I missed the first class, so I'm coming to this.
Oh, okay, good. So can you type in your email?
So is it a problem to attend the Tuesdays and Fridays class?
No.
Nothing, right?
It's here as well.
Okay.
That's correct?
Yep.
Wait, can you show me? Yep.
question regarding the Git repository that we would use. So I have this with my personal email account, the Gmail one, and I also have one with the CCS one, which is
Is
linked
it a Husky account or the CSS account?
Either one, whatever you prefer.
Husky. Because
Yes, either one. The one you read most.
no, the CSS mails also count the Husky account, so it's better to give the Husky account.
Okay.
So I was just wondering which one would be the
I would use the personal one. Yes.
Okay, so I'm actually not rushing this class right now. I'm trying to get it in.
Okay.
So should I talk to you or Professor Saul about it?
Brian Lackey.
Brian Lackey about that?
Yes.
Okay. All right.
All right.
Even though the classes are full, I mean, it looks like both sections are full. The Boston section.
I believe so. I think there's another one. Yeah, both sections I think are full.
Okay.
Yeah.
All right. I'll
All right.
email him about it.
Sure.
So, Professor, for 3 subjects in this SEM,
Mm-hmm.
and by the time I got approval from the Danny for that I can take 3 subjects.
Okay.
Your subjects was full. Like I'm not able to register
Okay.
this class. So, is there any way like you can increase like the capacity? I could
That only Brian Lackey can do that. You should ask him.
Actually, I had emailed him, but
What did he say?
I think he said like he won't be able to register.
He said no. Yeah, he's the ultimate.
So can I mark you in the CC and email?
I'm sorry.
Can I mark you in email as CC in the email and request him again, like if he can?
Yeah, he's gonna have the last word on that. Yeah, because he knows how many students I'm managing and things like that, and the workload and whatnot. So he's yeah. I think right now I have like 150 students. So I don't know that he's gonna.
But it doesn't matter. Like if the strength is 50, 51 doesn't matter, right?
Well, you and several others.
I can sit in the corner. Okay, I'm gonna put an email.
Okay. All right.
Hi, Professor.
Yes.
So, I am just done with my 3 semesters. So last time I took this course called Math.
Okay.
Yeah, so where we were involved in this kind of application called the person can open my web application and check the events around him.
Okay.
So that's a web application actually.
Okay.
So we were like a team of 4, and after 3 years we were very familiar with web development. So they were like very fast. They completed the coding application, and I was involved in petty things.
Okay.
And we ended up doing a crap coding.
Okay.
So I just want to know if I can make use of that same thought here and build a
Same-
robust application.
Same topic, you mean?
Yeah.
But building it from scratch, though.
Yes.
Yes.
Can I do that?
Yeah. If it's from scratch, yes. Yeah.
All right.
Yeah. You can build anything, even if it's something you were making, as long as it's from scratch.
I just want to know if that doesn't. That doesn't mean that I'm copying something, right? Because I'm.
No. Sorry. And I mean, how'd you build it? With what? What?
Exactly the same. The mean stack.
Oh, you use Beanstalk.
Yeah.
What course is this?
Managing software development.
Managing software development. You use Beanstalk. Oh.
The professor has assigned a project for us, so
Okay.
it's common through every.
Was it in the is it stored in a particular GitHub account? It's already
It's
there.
in the GitHub. I can provide that code also.
Yeah.
I can provide my code, like what I start from
Yes.
at this point.
It's okay that you do it, but it would have to be from scratch,
Sure.
and it cannot be the same. Obviously, it cannot be the same
Sure.
things, right? And I would try to make some modifications or improve on it, or now that you're familiar with the functionality,
Sure.
and I don't know that it will meet all the requirements that I'm going to impose on the project, right?
Okay.
I might add certain
Oh,
requirements that I mean, were you using any APIs, web APIs?
yes, we
or-
have been using the Eventful web API.
The-
That's from eventful.com.
Oh, okay. And you had user communication, talking one user, having some kind of relationship with other users, viewing each
Not
other's
too much.
profile.
So that's like the main course intent was to get acquainted with the agile development.
Yeah,
So
right.
for the namesake, he gave this kind of.
Yeah. Okay.
So we made up the basic thing, like he can log in and do the event search and then just log out.
Yeah. Yeah, no. So this is going to be much more involved. Then it's going to be many more use cases.
Yeah, because I lost my concentration over there. I was not familiar with Angular and stuff. I want to make use of that opportunity.
Yeah, you can use the same idea.
I can provide that.
But we'll add we'll add some more things to it. Okay.
Sure.
All right.
Thank you.
Cool.
I'm not registered in the class,
Okay.
but I really want to get registered.
Okay.
Is there a way you can accommodate another student? I mean, I've been checking if somebody's dropping the course every year. At this point. I didn't get it so far.
So
It's almost my third semester here. So.
This is your third semester?
Yeah, I didn't get the course. I mean, I'm a transfer student, so.
So send an email to Brian Lackey.
Okay.
Okay. See what he says. He's the ultimate decider on who, because he knows all the other sections and he knows all the other the workload on the various. There's a couple of professors teaching the same course. So see what he says.
I think
you can CC me.
This is one. I mean, you're the only instructor teacher.
Yeah, you can CC me. See.
Who is it that I'm supposed to be?
Brian Lackey. Brian Lackey.
Is he like the registrar?
He's I think he's the graduate coordinator in the computer science department.
Oh, okay.
Yeah. All right. Good luck. All right. Let's keep going. Okay, so we're talking about AngularJS. And so we're mentioning that AngularJS is one of several MVC JavaScript libraries, right, that forces you to think about your web application, your JavaScript web application on the browser, right? Think about them in a particular architecture, right? A particular template, right? This makes it easier, especially if you're in a team, to organize your content in a particular fashion, right? That makes things easier to find, identify what it is that you're working on, right? And if we all agree on the same pattern, right, then it makes it so much easier for us to find things and work together and collaborate. Another thing that Angular does is allows you to break up your large applications into various modules that they can then be included and extend each other, right? The other one is directives. Directives allow you to basically define new HTML elements or extend the behavior of existing HTML elements. Right? If you don't like how HTML behaves, you can just change it. Right? You can take over, all the elements in HTML, right, and change its behavior. If you wanted a new attribute that an existing HTML element doesn't have, you can define a new element. Okay, and that's how mostly it uses new attributes. It defines new attributes on existing elements, right, li or ul on table, so that you can use new attributes to be able to iterate over and copy paste lots and lots of LIs, right, inside of a UL, right, as you iterate over an array of objects, right, and allows you to copy and paste lots and lots of LIs as you manipulate the data model, right? So yeah, directives is it's a key feature of Angular. Also, routing. This is the main one of several modules, AngularJS modules, that gives you the functionality of being able to implement your navigation, but in a single-page application. Right? Navigation in a multi-page application is just what? It's just links from one page to the other page. We're not going to do that, right? We want that functionality, right? But implemented in a different way. Implemented in a single-page application without ever reloading anything, right? Meaning we only dynamically load the pieces that we need. So Angular routing, JS routing allows us to do that. So up to this point, notice that the first 6 weeks, up to this point, we've only been working on the client side. Right? We've only been doing client-side technologies, right? Basically, just HTML, CSS, and JavaScript, right? And in JavaScript, not native JavaScript, but a full-blown library of JavaScript. So, I mean, we will have been using a server, right? But a very simple server, a server that the only thing that it knows how to do is to serve pages, serve content, right? Serve static content, right? Meaning HTML is static, right? CSS is static, JavaScript is static, right? It's just static files. They happen to be run, right, and be dynamic when they get to the browser. When they get to the browser, then they're dynamic, right? JavaScript manipulates the page and whatnot, right, dynamically. But on the server side, it's static content. So up to this point, up to the 6th week, we're only talking about static content. So our server is going to look very, very simple. It's just going to be like 5 lines of code. That's it. Just pointing, telling where the public files are, right, where the static content is, and just tell it to serve all the content from there. When we reach week 7, we're going to start revisiting the server, right, and see how we can extend it, right. Up to this point, Angular has been manipulating the page, right, has been adding new content, but it has never had a chance to save it anywhere, right. It doesn't have a place to put that data that you're creating, this new content that you're creating, right. For up to this point, we've been working with mock data, right, with dummy data, right, with dummy arrays, dummy objects, right, but we don't have a place to put the data, right. So when we get to Node.js, we're going to start looking at, how do we fix that? How can we send data back to the server so that it can be stored permanently in a database, right? So we're going to start looking at Express. Express is it's a library, it's a module, it's a Node.js module that allows us to very easily create these servers, right? That that allows you. It's a library that allows us to manipulate or interact with HTTP, right? Angular can send data to the server using HTTP. It can ask for data from the server using HTTP. Right? So the way we receive and generate and handle and responses is the use of the Express library. Right? The Express library is a very, very easy, very, very powerful library that allows us to manipulate HTTP requests. Right? So up to this point, our server has been very simple, just sending back static content. When we get to Express, we're going to start looking at how we can generate dynamic content, right? And that instead of content, we got to be careful here. The content that we're interested in is data content, as opposed to visual content, right? The visual content is the HTML, the CSS, right? That's the visual content, right? And it's dynamically rendered on the client by the JavaScript, right? We're not going to be generating dynamic content, not for a while anyway, on the server. We're not going to be creating dynamic content on the server. The dynamic content is on the client. What the server is going to be doing is providing the data, right, that the client is going to need, right? The client is going to say, I need a list of recipes, right? Well, I don't have any on the browser, right? I need to go back to the server, ask for a list of recipes, right? And then it's going to hit our Express router, right? It's going to hit it and says, hey, give me the recipes. And the Express is going to respond somehow with an array of objects, right? An array of JSON objects. And then Angular says, oh, thank you. And it'll iterate over that array and render it using Angular on the browser. So we're going to see how we can generate this data, right, from the server. And Express is going to be useful for that. So, and the way we're going to respond to incoming HTTP requests is by using Express to build web services. So web services is an idea, right, of mapping incoming HTTP requests to executable code, right? Basically, that's it, right? Basically, it's just identifying a very well-known endpoint, a very well-known HTTP endpoint, right, that is mapped somehow to some executable function, right? Right, and Express is allows us to very, very easily map a get HTTP request to an existing function, right? And very, very easy, and so very easy to create web services. For instance, we might say, give me all the recipes, or post a new recipe, or get a recipe whose ID is so and so, right? Or give me all the users. Give me this user. Give me the recipes for that particular user. Give me that particular recipe for that user in there, right? So notice that not only are we interested in particular objects, we might be interested in how objects relate with one another, right? We see that perhaps there's a relationship between users and recipes. These are the recipes for this user. Those are the recipes for some other user, right? They might be stored in the same collection, right? But they have some kind of relationship with one another. Typically, if this were a relational database, we would do that with different tables, right? We would do it. We would have foreign keys and primary keys referencing each other, yes, and we would have to join them somehow, right? When we get to web services and NoSQL databases, we're not going to be joining things, right? We're going to be using a NoSQL database. It's a non-relational database, right? We store things differently in a non-relational database. Right? If, for instance, recipes only exist related to a particular user, if that's the only relationship that there is, then it makes sense that recipes, right, are a sub-attribute, right? It's a sub-array of a larger object of user, right? If the recipes instead are meant to exist on their own, right? Maybe I want to have a list of all the recipes across all users, right, regardless of who the user is, right, then it makes sense for it to be its own collection, right, instead of being embedded inside of a user, right? So it depends on the use cases. we will drive you to implement a data model one way or another, right? But at least you have a choice to either embed data or not embed data. Instead, in a relational database, you only have one choice, right? You have separate tables and relationship between them, foreign keys and primary keys. Here in non-relational databases using MongoDB, you have various choices on how you create these relationships. Okay, you can embed objects, you can have foreign keys, right? But anyway, to represent those relationships between the various pieces of data, REST, we're going to introduce a particular way that those HTTP requests are handled. Okay, so typically HTTP requests have been only considered for referencing a physical file, right? Index.html, right? Or recipes.jsp, right? These refer to physical files on a system, yes? On a virtual location in your file system, right? Well, URLs can be much more than that. URLs don't need to be physical, don't need necessarily be mapped to a physical thing, right? I mean, even a file system is a virtual thing, right? It's an abstraction. A file system is an abstraction, yes? Of some zeros and ones that are spread over, right, some, physical platter, right? The file system is an abstraction of that says, oh, there's some kind of hierarchical relationship, right? It's the way we want to think about how the file system is organized, right? So we can think of any abstraction. That's one particular abstraction. Another abstraction could be that a URL can map to something in a database, right? Again, a database is another abstraction, right? We can think of, we like to think of the data as being tables, right, and foreign keys mapped to one another. That's an abstraction, right, of some physical, zeros and ones, strewn across some physical platter, right? We can think of any abstraction, right? Another abstraction could be that, if I say slash user slash something something something, I want to map that to some object, some array. I want you to give me back some binary data. It's not a physical object at all, right? It's some piece of data. I can decide what I want, what URLs map to what. Make sense? So RESTful, REST web services is a particular standard or particular best pro we map, right, on how to organize your URLs so that they mean something. They mean, some piece of data, maybe an array of data, maybe one particular element in that array, right? And then other things that might be related to that particular object, right? So for instance, we might decide that that this URL, right? That URL, it's user. Which user? I haven't told you which user, so it must be all the users. Since I haven't specified which, you must mean all the users. So I'll give you all the users. Maybe no passwords, no nothing. It's a very clean list of users. Right? So this maps to give me back an array of objects. Okay? And I continue and I give you some ID, then that might mean that I want one particular user. That particular user right there. Okay? If I go on and say recipe, which recipe? Oh, since you haven't told me which recipe, it must be all the recipes. Wait a minute, all the recipes? Well, not all of them. Only the recipes for this particular user, right? There must be thousands of recipes. But I don't want all of them. I only want the subset which belongs to this particular user, right? If I give you an ID for that particular recipe, then it must be that it's one particular recipe that belongs to that particular user, right? And if I keep going, I can say, ingredients, ingredient, right? If I don't tell you which ingredient, it must be all the ingredients for that particular recipe. right? If I keep going and I say 456, then it's that particular ingredient. Do you see that? Right? So this is this URL. Well, this syntax of this URL allows you to navigate the data structure, right? Where you might have various tables. You might have a user table, right? That has a one-to-many relationship with recipe, right? That might have a one-to-many relationship with ingredients, right? And this URL, this syntax of this URL allows you to navigate anything, right? Anything and everything, right? Stored in this data model, right? So this particular syntax of organizing this particular meaning for this URL, for the use of this URL is what we refer to as a RESTful service, right? I give you this particular URL, it maps exactly to this particular resource, right? And if I give you the same URL, you're always going to give me the same piece of data, okay? Obviously, data might have state, and state might change over time. I added a new recipe. I removed the recipe, right? If I ask you today, I have 10 recipes. If I ask you tomorrow, I might have 12 recipes, right? But it's the data that represents the list of recipes for that particular user, okay? Okay, so we'll spend some time on data modeling, right? On talking about this design the data model that we're using and how we define the URLs that map to certain things. Okay. Another thing that we're going to be looking at here in REST, right, is that so the same idea that we have for data as we navigate through a data model is the idea that the URL that you type at a browser, right? The URL that you type at a browser should give you the view, right, that you should always get for that particular URL, right? The state of the application, right, should be encoded in that URL, right? So if I say, if I ask for a profile, right, and if I say, HTTP / my application / profile, right, for Alice. Okay, and that will give me the profile for Alice. I should be able to grab this URL, email it to somebody, right? And they should be able to see the same exact content that I am looking at, right? Even though, remember, we're only loading one file, right? We're loading index.html. It's only one file that gets loaded, right? The application Angular that we're going to be using should be able to decode this and says, they don't want to see the splash page. They don't want to see the home page. They want to see the profile page, right? And it's a profile page for this particular user, right? Okay, and that user, they might have on their Alice, they might have maybe some favorites, favs, right? There might be several tabs in Alice's profile, right? They might have the users that they're following, their favorite recipes, the things that they've bookmarked or something, right? So the page, what you see on the page, right, should always be reflected in the URL. Okay, the state of the application should always have a distinct set of states, a set of URLs that distinctly define what it is that you see, whatever you're looking at, right? So that if I grab this URL and I email it to someone, right, and they visit it from a completely separate browser, they should be able to see exactly what I see. Obviously, considering that they might need to log in, right? They might need to authenticate themselves. Maybe they need to be in a particular role. Okay, besides that, right? Obviously, right? But the point is, right, that the URL should always contain the unique, right, distinction, right, the unique identification of what you are looking at in the page, right? oftentimes we forget this, right? And we programmatically, right, in our code somehow, they're clicking, they clicked, and as they click, we update the user interface, right? Removing things and adding things, and it's the same URL. And you're making modifications programmatically, which is okay, but it's not being reflected in the URL. That means that if I grab that URL and send it to someone, they won't see any of the changes that I've done. See that? So somehow, right, the URL needs to be able to capture the uniqueness of what I'm looking at, right? Either, if I click and I do something, if the state of my application is changing, I should either, I don't know, some counter 1, then 2, then 3, then 4. There's some kind of history, right? I should always, well, if you want to, right? It depends on your use case. Maybe it doesn't, you don't care about saving certain things, right? You have to see how granular you want to be also, right? Right. But nonetheless, right? It's the idea that we want to be able to capture that URL and mean something. Okay. Again, the RESTful idea. All right. Okay. So, all right. Then after we're done with Angular and whatnot and RESTful applications with Node.js and Express, we're going to go into a break. Right. When we come back from the break, then we're going to start talking about database development. Database development. So up to this point, we've been doing client side, server side. So we've got 2 of the layers done, right? The client side and the server side. We're going to move on to the 3rd layer, right? It's a multi-tiered application. So our 3rd layer is database, right? And for database, we've chosen MongoDB, which is the M in the mean stack. MongoDB is a NoSQL database, right? Meaning it's it's not your classical database that typically all the database that you might have seen by now are the relational databases, right? And there's tons of them, and they've been around with us for forever, right? And one has to question, what would databases look like today if we'd be reinventing them, right? What would they look like if they solve the problems that we have today? Okay, today the data problems that we have today are much more different than what they looked like a couple decades ago, right? Today we're generating, just huge amounts of data, right? Every time I wave my phone, right, somebody's, the stream of data is being generated. Somebody's capturing that somewhere. Somebody's storing that and trying to understand why I did that because they want to sell me something. I'll get a tweet because I've waved my phone. Right, somebody's trying to gather information, data mine everything, right? And we're generating so much amounts of data that there's no way we could possibly, process all that data. We're looking for ways that aggregate the data, right? That data mine this data, that programmatically extract meaningful information, relationships, and identify all sorts of patterns, right? Only future AIs will be able to gather all these relationships, hopefully a friendly AI, and so the requirements today are much more different, right? We want data to be geographically dispersed, right, all over the world. We want to be able to have always availability, right? Even if we have machines that go down, we want some kind of redundancy that it could sustain, maintenance, of course, or if you have some disruption. And so MongoDB, allows us to do some of these things, right? And certainly one of the things that you lose or maybe you gain, depends on how you look at it. Some of the things that you lose is, for instance, joins that things that we become so familiar with in in relational databases, right, where well, you spread out the data, right, across many tables because you want to normalize, right? You still want to normalize here as well, right? But you do it differently, right? Instead of we teach in relational databases, you want to make sure that you reduce redundancy, right? If you have redundancy, you risk inconsistency, right? That's the mantra when we teach relational databases. Over here, it's a little more relaxed, right? We might have certain things that we check for the redundancy not at the database level, right? Although the database level could do that, right? We might check for the redundancy at the application level, at the logical level. Okay, we can check for those things logically, right? As opposed to always asking the database to do it for us, right? Instead of having joins and iterating over things like that, instead of having the database do that, we could do that at application level as well, right? And aggregate things at the application level as opposed to having the database do that. Instead of having the relational integrity, relational integrity, right, be managed by the database, we could have relational integrity perhaps managed also on the application somewhat, right? So we're asking a little bit less in certain respects from the database, right? But we're moving some of those responsibilities, one layer above, right? Also, for instance, one of the things that the relational databases impose is schemas, right? Where a particular table has a certain set of fields. Those fields are all of the same data types, right? Also, we lack those kinds of things, right? Instead of imposing that on MongoDB, MongoDB does not impose any schema, right? A collection can have all sorts of mixed in types of objects and documents in there, right? One document can have 10 attributes, right? Another document could have 20 attributes, not necessarily of the same names, not necessarily the same data types. It's anarchy, right? It says, how could you? What about validation, right? You want to make sure that the data type that's going in there is, if I was asking for dates and you give me a string, you get an integer, right? What's the validation here? It's anarchy. Again, some of that responsibilities, we're going to take those responsibilities and move it up one step higher, right? For that, we're going to introduce Mongoose. Mongoose is a library that takes care of a lot of these things, right? That gives some sanity for the anarchy, right? We're going to use Mongoose to create schemas, right? To do some validations, to do some default values, right? To handle some referential integrity for us, okay? But again, those responsibilities are now part of a library as opposed to part of the database. Although the database can also take some of those responsibilities as well. Okay, we'll talk about schemas and creating models. Creating one-to-one, one-to-many, many-to-many, and mappings. Right. We'll see that, and not only do we have what we're already familiar with, the having foreign keys and primary keys and things like that. Not only do we have that way of organizing our data and relationships between the data, we have other ways of relating things, right? We can have objects that are embedded in other objects, right? You can have nested objects, nested attributes, right? Things that we couldn't do in relational databases, right? You can have arrays instead of objects instead of arrays, right? Actually, the data that's being stored that we can store directly on MongoDB is just plain old JSON. We can store just plain old JSON data that is already friendly, right, to the JavaScript that we're using on the client. The client, the JavaScript, the Angular on the client is using JavaScript, is using JSON, right? It's the native storage of MongoDB, right? So we have JavaScript on the client, we have JavaScript on the server, Node.js. We have JavaScript on the database, right? JavaScript everywhere. One language to rule it all. Okay, JavaScript is taking over the world. So yeah, so we'll spend some time on querying, updating, inserting, interacting with MongoDB through Mongoose. There's several other libraries, but but Mongoose is one of the more popular libraries that interact with MongoDB. So yes, we'll spend a couple weeks there, and then we'll spend another couple weeks talking about how to do user management, right? How to register users, how to log in, how to protect content, right? And show appropriate content depending on who you are, right? And what particular role you might be in, right? We like to do authentication and authorization, right? First, I want to know who you are. Right? Now that I know who you are, I want to show you the information that you're entitled to, right? We're also going to be able to introduce how we can use third-party authentication authorities, right? Such as Google or Facebook or LinkedIn or Twitter, so you can log in through your application using these third-party entities, right? So we'll use Passport.js. That's another Node.js module specifically for that, and that's going to be our last assignment, security and user management. Before our last topic, dynamic server pages. So I know there's an assignment there, but I'm not going to have that. I'm going to remove that. Dynamic server pages is a little bit what you might be already familiar with if you've done JSPs and ASPs or PHP or Python, right? If you've written dynamic pages, right, on the server side dynamic pages, you could do the same thing with Node.js, right? You could do dynamic content on the server, also Node.js, right? Using what is called embedded JavaScript. So instead of embedding Java or embedding C# or embedding PHP or embedding these other languages, you can embed JavaScript, right? And they are interpreted on the server. They're compiled. Well, no, they interpret are not compiled. They're interpreted on the server, and they generate dynamic HTML that then goes to the client, right? Notice that I left it last, right? Although it is an important topic, well, something had to be last. There's still a place for server-side content, right? Dynamic server-side content, right? Angular, it's very nice, right? But it's not as fast. It can never be as fast as something that is generated from the server. It can never beat the server. Okay. So, for instance, pages that might be very important, like for instance the first page, right? I don't want to wait anything on the first page. I want to give content right away, right, as soon as possible, right, to try to have the user see something, right? Because users have become very fastidious, right? Very, if you take more than a couple milliseconds, I'm gone. I'm going somewhere else, right? So if I want to, maybe it could be a static content, right? It could be as easy as just static content, no JavaScript, no nothing. It's just plain HTML. I'm going to try and put content as fast as possible to you. But if it has to be dynamic, then I need to hit a. Maybe I have a cookie and I know who you are, and I want to give you, to Amazon, I want to give you, the products that might be related to you, right? Because I know who you are. That's dynamic, right? Well, the fastest way is to do that on the server. Right? Dynamically generate that content in the server and push it to the client as fast as possible, right? If this were Angular, yes, we could have dynamic, some static content first, right? And then Angular, go back to the server for data, hit the database, and then we could have lots of spinning, right? Things that are kind of waiting, right, for the content to load, and then we display it after a little while, right? It would be slower than a dynamic server page, right? Nevertheless, I thought it was one of the least interesting topics, since I'm expecting you that you've already seen server-side content, but nevertheless, it's something that you should be aware of, that it's also available here, and that it's also important. Anyway, the last 2 weeks. This last week, the 15th week, is our last week of classes, of lecture, but I am not going to have lecture that week. I am going to be grading projects, okay? There's 150, maybe more, that I need to grade, and I'm going to need 2 weeks to do that. Historically, that's as much as time as I've needed. So officially, projects are due April 19th. Projects are due April 19th. Okay? Right? Nevertheless, many of you historically have come to me and said, oh, but there's 2 more weeks to go before grades are due. Couldn't I just add this new thing? Can't you just give me some more time to finish up a couple of other features? Can't I just polish this a little bit more? So what we'll say is that, okay, fine, but it's due on April 19th. You can keep working if you want. You can keep working if you want, right? But I am going to randomly choose students, and I'll just have to choose someone to go first, okay? And that student will be, the unluckiest of you. That's okay, because projects are due April 19th, right? Right, so by April 19th, you should be all done, right? Maybe you have a couple misspellings here and there that you want to fix up. Maybe you want to tweak a little bit of the look and feel, right? Maybe you want to make it look a little more polished, okay? But I don't expect you to be doing any major coding after April 19th, right? Maybe you have a bug that you're working on that you want to come to me and see if we can fix it. That's okay, all right? But I don't expect you to be doing any major development after April 19th, right? But if you're going to keep working on it just to polish it and do a couple of things, that's fine. Whenever I'm going to grade you, I am going to send you a text. So I'll need your phone. I need your phone. I need to text you. I'm sorry if you've gone and you're in India and you can't receive texts, or if you've gone earlier. I mean, I need to be able to contact you to let you know. If I can't contact you, I'm just going to go and grade you. All right? If I can't contact you, I'm going to send you a text. I'm going to give you a chance to respond to me and saying, okay, that's fine, or give me 20 minutes so I can do my last push, right? My last commit, all right? I'll give you a chance to maybe clean up a couple things, and that's it, all right? And then that's it. I'm going to grade you, and that's what's going to be, all right? So after April 19th, you should be, anytime you should be ready at any moment to be graded, okay? At least I'm telling you. At least I'm texting you. Before, we used to not even let you know when we were grading you. So you could be working and you already had a grade. Although I like that, because you would have kept working, and that's learning, right? You keep working, you keep learning new things anyway, right? So and that's all we're here for, right? Learning. Anyway, grades are due 2nd of May. So obviously, this is going to be Thursday, Friday, Saturday, and Sunday are going to be very, very hectic time for me, right? So I'm going to I'll probably be unavailable, all right, this last week, because I'm going to be rushing to hit that that date. Okay. All right. All right. So let's talk about the first module. So in the first module, first week, each module, right? So this module is 1 week long, right? And the goal of the development environment is for you, by the end of not this Friday, by the end of next Friday, to have a working development environment. Okay. And there's an assignment for this module, which asks you to put together a development environment, right? And so each module, notice that they all have the same pattern, right? Overview, a course map that tells you more or less where you are, and the things you should know already by the time you get to this module. And then they have lectures, right? So several lectures, each lecture having several videos of which you're all responsible for this content to look at this HTML, all these videos, right? So you're all responsible for this, to look at this, right? And they all have the same pattern, right? Overview, course map, lectures, and assignments. So each one has assignments. Some of them have 1, some of them have 2. Okay, and they're all Google Docs. Right? They're public Google Docs that you can read. You can make it big so you can see it in your Google Docs user interface. So they all have that pattern. Beyond the assignments, some of them have additional tabs with examples. Right? There's lots of examples you can look at. Right? Each one has some blurb, some HTML, and then source code that you can look at. You can look at HTML. There's several files for each example, right? Some of them have HTML, CSS, JavaScript, some Node.js, some stuff, some database stuff, right? So you can look at different content for that particular experiment, for that particular example. So you're also responsible to look at these examples. Look at these examples. Ooh, how do you do that, right? Let me look at the source code, right? So source code is already there. You're responsible for looking at how we did that, all right? So go over the examples. For the first module, there are no examples, right? We're setting up an environment. But there is an assignment. There is an assignment. I'm going to open it up in Google Docs. And what this Google Docs does is that it asks you to set up a development environment. Right? It asks you to install GitHub. To open an account in GitHub if you don't already have a GitHub account, preferably a personal GitHub account, not necessarily the school's GitHub account, right? A personal one. With GitHub, I will be able to follow your work. I'll be able to see a history of your work. I'll be able to see if you have been working consistently throughout the semester. And I expect that you will have been working consistently throughout the semester, right? Even small little things each day. I'd like to see that you touch the file, right? You fix a spelling here and there, right? We used to ask students to keep a blog of what they were doing. There's no need to do that, right? GitHub keeps track of everything you're doing. All your commits. What the file used to be, what it's now, right? I can see a day-to-day progression of what you're doing, and your consistency will affect your grade. Right? If I see that you haven't done anything for the first 2 months, right, and all of a sudden there's one big commit at the end, right, that is not going to be very favorable. Okay, I expect to see consistent all throughout. Right. So GitHub allows me to do that. I'm asking you to create a repository called web development, and I just thought that this should be web development spring 2016, because then I'm gonna have a heck of a time trying to figure out the one when I get to the fall and try to distinguish these. Okay. So web development spring 2016. Maybe we can shorten it a little bit. About web dev spring 2016. Yeah, so create a repository called web dev. If you need to have a Git client on your machine, right? If you have a Mac, you already have a Git client, right? If you have a Windows machine, you can download one from here, right? And tell it to yes, you want the command line tools, right? So you can interact with Git from the command line, okay? And I would ask you to please invite the TAs and myself to be collaborators in your in your repository, right? So we will be able to then see exactly what you're doing. We'll be able to, if you run into an issue, we'll be able to help you right away. We'll be able to clone your assignments or clone your projects, right? Run them locally on our machines, right? Make any fixes and push them back onto you. So that'd be a beautiful collaboration tool, right? If you need help right away, we can help you right away with your code, right? We can jump on a Skype or Google Hangout, right? And we can help you right away, okay, without having to be in the same room, right? Then I ask you to install Node.js, right? So I ask you to first download and install Node.js. Right? Go to nodejs.org, right? And install the latest version of Node.js onto your machine, right? Node.js should add itself to the path, right? So that you'll be able to invoke at least 2 commands we're going to be using mostly in Node.js. One of them is Node.js itself, right? Node.js, the only thing Node.js is a JavaScript interpreter for the desktop, right? Typically, when we think about JavaScript, we think, oh, it's the language that you use to program browsers, right? To program web pages, right? Well, JavaScript is more than that, right? Node.js allows you to run JavaScript, but on the desktop, right? From the command line, right? That's all it is. That's all Node.js is. Obviously, there's some differences on a browser. I can open up a window, right, from JavaScript, right? I can manipulate a DOM, right? I can manipulate the page. I can remove things from the page. I can add new content to the page, right? I don't have anything like that in desktop. I don't have a browser, right? I don't have a window. It's all console. It's all console. So in that respect, I'm limited because I don't have a UI. There is no UI here, right? But I have access to the file system, which I didn't in the browser, right? Here, I have access to the file system. I can write to the file. I can read from the file, right? I can in the browser, I can't do a network connection just anywhere I want. I can only make a network connection from the server I came from, right? I can't just go and make network connections anywhere, right? Whereas in the desktop, I can connect to anyone I want, right? I can do posts and puts and gets any server out there. I have freedom to do all sorts of network connections. In the client, I don't have access to any data, right? Unless I fetch it through some HTTP, right? I have to go out and do some network connection. On the server, right, on the desktop, I have full control. I have full access to, I could do a database connection to MongoDB, SQL, anything I want, right? So it's 2 different worlds, same language, right? Okay, so it asks you to, once you install Node.js, it asks you to create a little, hello world, hello.js. That's it. That just says console.log hello world, right? Console.log on the browser, it displays on the console, the JavaScript console on the browser. Console.log on the server, on the desktop, it just prints it out to the command line, right? All right, so it asks you to do that. Then MongoDB, it asks you to install MongoDB, even though we're not going to use MongoDB for a couple of weeks, right? Anyway, I'm asking you to get going, download MongoDB, the latest version of MongoDB, and configure it. There's a link here that tells you how to configure MongoDB. Okay, there's only 2 things that you have to configure. One is the directory where to store the databases, and that usually is just /data/db, right? So you have to create that directory, right? MongoDB will ask for that directory. And the other thing you need to configure is MongoDB installs a bin directory that has a whole bunch of executables in there. Okay, just add that bin directory to your path, right? Or either using Windows or Mac. You should be able to run Mongo, right? Type Mongo from anywhere in the terminal. Okay, right. what else? Yeah, data.db and the path. Also, I'll ask you to create an account in OpenShift. So OpenShift, all your assignments and your projects are going to be hosted live on a server, on a real server out there on the internet. Okay, and I am suggesting to use OpenShift, right, as the host server, as a host service. Okay, OpenShift is a Red Hat company, right? And so you see a lot of branding, a lot of Red Hat branding, right? It's their platform as on your server as a service. Okay, so you can create servers, right, that run on their networks. Okay, they're free. Excuse me. They're free if you stay within certain boundaries, right? It allows you to have an instance of a server, which is going to be a Node.js server, an instance of a database server, which is going to be a MongoDB server, and anything else, right? Typically, you'll want a MongoDB client, right? So you can interact with the remote database, the remote MongoDB. Okay. So in OpenShift, what I'll ask you to do is open up an account at OpenShift.com. So OpenShift.com. Open an account for free. Invite me and the TAs as collaborators. Right. Well, sorry. First, you'll create a Node.js application. It'll ask you, do you want to create a new application? You'll say yes. It'll tell you what type of application do you want. Do you want a Java application, a PHP application? What do you want? Right. It can host all sorts of frameworks. Okay. You'll say, I want a Node.js application. Right. And it'll create a dummy, a simple, a trivial Node.js application. Once you create that application, invite us. Invite me and the TAs. I'll give you the username. My username is just Janunzi, the same I use for my email, Janunzi. Invite me as a collaborator. So OpenShift has its own Git servers, right? But that Git is much more restrictive, right? I can't track your history, right? If you invite me, I can see your source code. Right, I can clone the source code from there, so I can see the files and everything, but I don't see any history. I don't see what you've been doing. Well, actually, I can see the history of each file, but I don't see graphical history of what's going on, of your commits and whatnot. Right. So what I'm asking you to do is to keep track of these two Gits. Right. One is a mirror of the other. Right. Your OpenShift Git should be your main Git account, right? You're going to be committing and pushing to your OpenShift Git, right? But whenever you push to your Git, to your OpenShift Git, I'm going to ask you to also, please, right there when you push to one, also push to your GitHub. Because GitHub will allow me to keep track of what you're doing. All right? Okay, will allow me. The OpenShift Git won't allow me to keep track of you, right? So one is for grading, the other one is for development. Okay. You can create if it's too much typing two Git commands, you could put it in a shell or in a bat file or something. You type the command, it'll run one and it'll run the other. Okay, if it's too much. Okay. So OpenShift, create the account, download. There's a couple of development tools that you need to download. One of the things, if you're on a Mac, I think you should be all set. You need Ruby installed. And if you're on a Mac, I believe you already have Ruby. Okay. If you're on a Windows machine, you'll have to download Ruby, right? And a couple of tools that you need to download. One of the things that you need to do is create private keys, right? To make sure OpenShift wants to know that it is you who's pushing and sending data, right? So it wants you to be able to authenticate you, right? That it is you who's sending this data back and forth. So that is done through the development tools, and there's documentation for that. Please read through that, right, and install those tools. The main tool there is RHC. RH is for Red Hat. Okay, and it's a tool that allows you to create applications, create the keys, publish those keys, right? Log in, log out to your application. It allows you also to remotely log into the remote server, right? If you want to look at the logs, right? If you want to see what's happening remotely, you can do that as well. And finally, I'll ask you to download the WebStorm, download and install WebStorm. And from WebStorm, you can give it, in the OpenShift, it'll give you a URL of the Git repository. It'll give you the URL of the Git repository. You can copy that URL, go to your WebStorm, and say check out, right? Download, clone that repository locally. Just bring it down. It'll copy it locally on your machine. Now on your machine, you have a copy of all the remote source, right? It's a single file, really, you care about, server.js. It says here in the documentation. And now, because you have a local Node.js, right, you can execute whatever's stored remotely on the remote server. You have a mirror image in your local machine, right? So now you can do all local development. You can run your server locally. You can do all your testing. And once you're happy with your implementation locally, you says, oh, this is good. It's at a stable. There's no bugs. I'm going to commit this. I'm going to push it, right? It pushes it to the remote server, to a remote Git repository. It deploys your code, restarts the remote server, and within a couple of seconds, you'll have whatever you had locally running on your machine, you'll have it also running remotely. Okay? And now you can do most of the interaction with the Git repository, most of it, you can do it right from within WebStorm. Right? So you won't have to remember the Git commands to interact with the Git repository. You can do it all from WebStorm. You can also use the command line tools, right? But WebStorm gives you a nice UI that allows you to commit and push and whatnot. Okay. I do ask you the default web application that their hello world. When you say that I want to create an OpenShift, I'm sorry, a Node.js application in OpenShift, it creates a server.js file. That file has to have that particular name. That represents the server. It represents what the server does. It is the server that is actually listening for the incoming HTTP requests. When you type, HTTP:// yada yada your URL, da da da. It is this that is accepting and listening for the incoming requests. Okay? Right? Well, their server.js is a little bit involved. Okay, so I'm going to ask you to make a simpler version of it. Okay? I'm going to ask you to use this code here to replace their server.js with this server.js. Theirs is several dozen lines long, right? I'll ask you to instead replace it with this this hello world. Okay, it requires the Express module, right? That allows you to listen in for incoming GET requests, and it maps this URL, this incoming URL. And it maps it to this function. If this incoming URL comes in, this function gets executed. It receives objects that represent the request and the response, right? And it uses the response to send back text that says "Hello World," meaning that if you type at the URL localhost, right, listening at port, which port? Port 3000. So if you type localhost 3000 / hello, no, you should get a hello world. Right? You know that Node.js is working. Okay. Also, another thing that is here is that it's configured to work both locally on your machine and also work in the remote machine. Right? The way it's configured to work remotely on the machine is because it's using these environment variables. Right? It's running on their remote machines. They are using their own IP address, right? They're using their own port number, right? Not necessarily the same port number that we use, right? It's whatever their port number. We don't know what those port numbers are. We don't know the IP address of their remote machines, right? So they're stored. They're made available to Node.js through these environment variables. Right? So what this says is IP address, use this IP address, right? And for port, either use this environment variable, or if it's not defined, use this instead, 3000. Okay. So if it works, if it is defined locally, it uses 3000. Actually, this should say, sorry, or 127.0.0.1. That's localhost. Okay. So if it's local, right? If you're running it locally on your Node.js on your machine, right? This will not be defined. This will not be defined in your local machine. So it'll choose this instead, this string, right? Same thing here. If it's running in the remote machine, this will be defined, and it will choose that remote port. If it's not defined, it will use the 3000. So locally, it will use port 3000 and then 127.0.0.1, which is localhost. But remotely, it'll use whatever port OpenShift gives me, right, and whatever IP address Red Hat gives me. Okay. So this is a way to make sure that it's working locally and it's working remotely. It's a very trivial set of lines, right, to make sure that now you're ready to start really developing. Okay. Okay, so here's where I ask you to have the two gits. You're already going to have the git. You're already going to have the git from OpenShift, but I'm also going to ask you that have the second git, right? The one WebDev Spring 2016, right, with that repository. So it's going to be. So you're going to add this other remote to your git, right, which is going to be GitHub, your username, whatever, and the repo name, which should be, WebDev 2016. Should be that repo name. And commit. Okay, so you're committing you're replacing the server.js. You're committing it. You're pushing it. And when you push to both. Push to the push. This will push to OpenShift. So it will deploy. It will copy your files, deploy, and restart the OpenShift server. And then I'm asking you to also push to the other remote, your personal GitHub account, which is available to me, which I can see your history. I can look. I can keep a track of you. I'm suggesting that you call it WebDev, right here, right? Here it is, WebDev. You push, right? So now you're going to have the code in OpenShift and the same exact code in your GitHub, your public GitHub account, right? One of them, it's deploys and it's available for your server to run, right, on the end. The other is just for tracking your work. Okay. Deliverables, there will be assignments on Blackboard, right? But only to keep track of your progress. I don't need you to submit anything, right? And all your files will be available on GitHub, right? The only thing I'll ask you to do for the first submits, for the first assignment submit, you need to submit the URL of your GitHub, right? I'll ask you to submit also the URL of the application of your on OpenShift, right? It should be, I think I suggest a name for that. I suggest that your application should be Web Dev 2016, last name, first name. Okay? That should be the name of your Node.js application, right? That you're going to be using throughout this course, right? Under there, you're going to have your assignments in there. You're going to have your project. You're going to have a home file, a home index file, right? Telling you a little bit about yourself. I guess I should ask you a couple more things. I might ask you also your mobile number. I'm going to need to make a spreadsheet of everybody, right, so that I can text you, or in case I need to grade you or something, get a hold of you, and your preferred email. Okay. All right. I didn't go over my projects. Oh man. Nevertheless, they are available if you go to resources. Resources. This is a list of project ideas. Right. There's quite a few, and if we can't agree on a project, right? Actually, I would love for all of you to just work on my projects. But I'm going to leave it open-ended, if you want to work on something. But I would start thinking about projects right away. Okay, the earlier you can start working on it, the better. You can start wireframing it, or planning what the pages are going to look like and what the navigation is going to look like. You can already do that. Right? You can start doing that today. Okay, that proposal won't be due for another couple of weeks, but if you can start working on that right away, start making an appointment with me to talk through the projects. I'd love for you to grab one of these projects. We can work together. All right. I'll talk more about the project ideas next week. All right. Here's a couple of projects from last semester from other students that have worked, so you can link it to see what they've done. What else? All right, I'm gonna leave it here. Yes.
We have a list of the TAs and like the usernames that we need to add.
Yes, each TA will present themselves on Piazza, and they're also gonna offer office hours when they'll be available, and they're gonna poll the class. When would you prefer? We'd like to try and spread out throughout the week so that we have coverage throughout the entire week. On Mondays, I won't be here Mondays, so that'd be a perfect time for the TAs to be here. And please use the TAs. Okay, they've gone through the course already. They've gone through many of the challenges, all of the questions that you're going to run into. Why my RHC is not working. I can't get the server started. Why is MongoDB not running, or whatever? They've gone through this. Okay, and they're very great. It's a great resource for you to go to, and they can help you out. They're more than welcome for you to go and ask for help. Okay, many times they come back to me and says, nobody came to see me. I was there for 2 hours. Nobody came to see me. Right. So please make use of those resources. Don't wait to the last minute and then just all of a sudden nobody has come to see me the last 2 weeks, but today I had 20 people. Right? It'll be much harder to be able to serve all of you. Right? Try to spread it out over time. Okay. All right. Thank you.